So I think we can start now. Okay, good morning again, everybody. So we are very happy to welcome all of you for this second winter school of E-PiCo Master. So before opening and starting the program of this winter school, I would like to thank very much all of the interveners for supporting the master by giving a talk and share their e-mobility activities. So concerning the program of the first day, as you can see here, we will have 5 presentations, 3 in the morning and 2 in the afternoon. So before giving the floor to the interveners, I will briefly say some words about the master and present the e-mobility control activities at Central Nantes. So about E-PiCo master, it is an international master supported by the European Union within the framework of Erasmus Mundus program, Label of Excellence. E-PiCo is unique in the field of electric propulsion, traction, and its control. As you can see here, E-PiCo is built within a mobility scheme for students, and it is coordinated by Central Nantes here, with the participation of 3 academic partners from Europe, namely L'Aquila University from Italy, Bucharest University from Romania, and Kiel University from Germany. So the master is also supported by associated academic partners, as you can see here, ETS from Montreal, Canada, Wuhan University from China, and Sinsta from Mexico. And it is also supported by industrial partners. So the role of associate academic partners and industrial partners are to participate in updating the program, to give lectures during the master winter summer schools as it is today. So in order to motivate students and interested in the future of electric propulsions, they can also welcome students in a master internship or thesis and give lessons. So now about the e-mobility control activities at the Central Nantes. They are mainly focused on the chair program between Renault and Central Nantes, as you can see here on the website of this chair. So this program chair is defined around 3 research axes. The first axis is, as you can see here, deals with the control of AC machines and the static converters for electrical vehicles, powertrains. So the second axis treats the energy management problem and control of EV, electrical vehicle chargings. And the third axis is focused on energy optimization of hybrid powertrain systems. So the main objective of this program chair is mainly to use advanced methodologies and technologies in the control of propulsion systems in order to reduce the cost of electric and hybrid powertrains, to make EVs and HEVs affordable, while of course keeping a high level of requirements on their performance, operational safety, and reliability. So now we will go back to the program of the first day of this winter school. So now I will give the floor to other interveners and partner institutions. L'Aquila University, Bucharest University, and Kili University. Stefano, Octaviana, Marco. I don't know who want to start to present the institution.
If you wish, Malek, I can start for the University of L'Aquila.
Okay, Stefano. So I will stop my to share my screen and give you the floor.
Okay, thank you. So this should be the presentation. So good morning to everyone. I'm Stefano Di Gennaro from the University of L'Aquila, and I will briefly present some aspects of the L'Aquila University. L'Aquila University, L'Aquila, first of all, is a town which is just in the middle of Italy. Literally, it is in the center of Italy. Let's say 100 kilometers from Rome. And it is a medium-sized university with 7 departments, 4 centers of excellence, and 4 other centers.
Sorry, Stefano, to interrupt. The screen is black. I cannot see your PowerPoint.
Oh, that's strange. I can see it.
Now we can see, yeah.
Yeah.
So maybe, let's see, do you see it now?
No. Black
No.
screen.
So it is a problem, a software problem. So I will present. I will present in this way.
Yeah.
It is much better. So we'll see. No, you are welcome. L'Aquila, as I was mentioning, is a medium-sized university located in the center of Italy. And so you can get L'Aquila by, first of all, arriving by plane in Rome or in Pescara. I suggest you Rome clearly because the flights are more frequent. And then you need to take a bus directly from the airport. But in this case, please check the bus timetable. There should be at least 2 companies of buses that serve the line from Fiumicino Aeroporto to L'Aquila. Or otherwise, you can go directly to Rome by train and then take the bus for L'Aquila. And from Pescara, more or less is the same. You can take the bus. So I suggest the first solution. This is the first aspect. The second aspect is to find an accommodation. We already met the students that will come in L'Aquila for this second semester. And they know that for accommodation, practically you have to contact private owners. Usually the apartments are furnished and equipped with all the basic essentials. But our team, in collaboration with the ESN Aquilasmus team, can offer you alternatives, always with private owners, and so that we can choose. You can choose among different options. Clearly, you can also look for yourself and see if you can find a better accommodation. Because clearly there are also dedicated Facebook social networks or rental website pages where you can find other alternatives. When you arrive in L'Aquila, we suggest to do some basic things. First of all, buy a SIM card, because otherwise you have problems in connecting yourself to internet and etc. But bureaucratically speaking, you need first of all to get the Italian tax code. You have to go to the revenue agency called Agenzia delle Entrate, and to have it, to get it, it is pretty easy. Then you need to apply for residence permit, or the so-called declaration of presence, and within the first 8 days from your arrival in L'Aquila. And we will give you updated guidelines just before you are planning to arrive. Then you have to enroll to at the university, and in that case you need to make the so-called pre-enrollment, and all the students have already done this. So this step was already done. Then there is the physical enrollment at the student secretary, where we have a person dedicated to these aspects that who can help you in doing this. But probably you already had contacts with her. And in any case, we will be in backup to help you for any step in this process. But physically, I think that you have already done all these steps. But just in case there are some further aspects to tune, we will be there and help you in doing this. So we are planning also to do a welcome week, but not immediately, because you know, L'Aquila is a quite cold city, so it is better to postpone this welcome week to a better moment in springtime. And we will organize this welcome week and orientation days, in which you will know better the campus, the city, and other peer students. So it will be a social moment, very interesting. So it will be dedicated not only to institutional meetings or presentations, but also guided tours of the city, excursions, etc. As I mentioned before, there is an international exchange Erasmus student network, Aquilasmus, which is an association specialized in organizing social and cultural events for international students. They also provide support for bureaucratical or logistical aspects like housing, residence permit, etc. For instance, I suggest you to get the ECN card. It is just 10 euros, which is valid for 12 months and give access to various discounts, companies, shops, museums, and so on. I suppose that all of you already got the vaccination cycle. So the third doses, the vaccine, or the 2 doses Johnson plus the other doses, the booster. So the Green Pass has been issued already in France, I suppose, and you don't need to ask for any, let's say, conversion in Italy. But in any case, please address to us any question in this regard, and we will help you to do everything that has to be done as soon as you arrive in Italy. So just to give a glance to the master degree program in L'Aquila, this is hosted in the Master in Computer and Systems Engineering. which has 3 curricula. One is control systems engineering, whose major is automatic control. Then information technology, whose major is computer science.
So just to give a glance to the master degree program in L'Aquila, this is hosted in the Master in Computer and Systems Engineering.
I hear a
which
voice.
Has 3 curricula. One is...
Okay, we had the technical problems probably. So the third is E-PiCo, the E-PiCo problem, which is your cultural path that you have to follow. So now you are in the first semester in Central Nantes, and you will move to L'Aquila for the second semester. This is a scheme of the mobility of that we have already seen about E-PiCo students. And in the second semester in L'Aquila, you will follow some courses like nonlinear control systems, hybrid systems, power electronic converters, electrical machines, renewable energy and storage systems, and the Italian language course, which is customary to the Italian path. In the third semester, for whom will remain in L'Aquila, we have yes, because clearly in the third semester you can choose to go in the other 3 universities. Who will remain in L'Aquila will have to attend systems identification and data analysis, advanced control systems, embedded systems, and optimization models and algorithms, which are just 4 exams. The most important thing is for the students that go to the other universities in Kiel or Bucharest or in Nantes. In any case, they will be enrolled to the L'Aquila University so that you can participate to the mobility projects, let's say Erasmus, Erasmus traineeship, agreement with other institutions, and so on and so forth. And this is interesting for you because, let's say, a student that goes to Kiel can get the Erasmus support in the case that he has no scholarship. Or maybe he can have a scholarship to go to one of the other institutions like Simvestav and ETS to do the his or her thesis. So in any case, you will remain a student of the L'Aquila University also for the second year, even if you go to other institutions. In the fourth semester, clearly it is dedicated to thesis, and we will present at the proper time a list of topics on which you can do your thesis. But this is just to give you an idea of possible thesis that can be done in L'Aquila. Maybe also in collaboration and especially in coordination with industries that participate to the program, but not only. So we are working to enlarge the group of industries that will collaborate with us so that you can find interesting topics. Just to give you a quick glance of the educational system in Italy, we have a different way to give you grades that are in number, but from 1 to 30, and let's say different from France, which arrives to 20. Then there is a conversion scheme that we agreed with the consortium, in which, for instance, some grades correspond to A, the other grades correspond to the B letter, and et cetera, et cetera. So we have a conversion scheme that was established with the consortium. And yes, I'm the coordinator, Stefano Di Gennaro, coordinator of the of E-PiCo in L'Aquila, but there are other people that work with me and in collaboration with me, starting from Letizia Giorgetta, who will for sure give you a lot of information, help during your stay in L'Aquila.
Good morning, everybody. I'm here.
Good morning, Letizia. Also, there is a clearly personnel from the student secretariat, and in particular Simonetta Di Giacomo, who will help you for all the stuff for the enrollment at the university. So this moment I will stop and see you soon in L'Aquila. Thank you, Malek.
Thank you. You're muted.
Maybe you have to unmute, Malek.
Okay, thank you, Stefano. Yeah. My microphone was off. Okay, thank you for this presentation, Stefano. So I don't know if Thomas sent to me an email asking that he can at 9:45. So Octaviana, if you can present the activities of the master from Bucharest University.
Thank you. I hope you hear me and you see also my presentation.
Yes, it's perfect. Thank you.
Thanks.
You're welcome.
Good morning, everybody. I'm Associate Professor Octaviana Datcu from the University Polytechnic of Bucharest, Faculty of Electronics, Telecommunications and Information Technology. Together with Professor Dan Alexandru Stoichescu, I am the local coordinator for the E-PiCo program. And our colleague, Oana Bugan, is the one who can help you with all the administrative details, because each situation is particular. So you feel free, please, to contact us for the administrative part, Oana Bugan, and for the academical part, I myself and Professor Dan Stoichescu. The Faculty of Electronics, Telecommunications and Information Technology is located in Bucharest, which is the main city of Romania. So it will be very easy to come to Bucharest to come to Polytechnica University from the airport in Bucharest. We have a large green campus. And in this campus, there are 15 faculties, among which the electronics, telecommunication and information technology, our faculty is one of them. Here there are all the 15 faculties. As you can see, there are 2 metro stations next to the campus. Our faculties offer bachelor, master, and PhD programs in several domains. You can visit all the campus, and also participate if you want in some of the scientific activities of all the faculties. We have several programs in Erasmus Mundus, double degrees, European projects, and also multiple industrial partners. Among these partners, we are surely interested in vehicle partners. So Dacia Renault is one of the greatest industrial partners. Also, Microchip, located a few steps away from our faculty, is a huge industrial partner, which can who can organize internships if you want. You will have later on these days one of our collaborators talking to you about their activities in Microchip. You will also have these days talking my colleague Lucian Perișoară about the laboratories we have here. About the electric vehicle propulsion and control local master program, I'm sure you already know that the first 2 semesters are a common curricula among the partners, the academic partners, and the 3rd semester, as you already know, is a specialization semester. So here we have organized a little bit our objectives for this master program, but my colleagues already told you about them. So I think all the details can be deepened, can be talked about by email. So I'm going to the end of my presentation to remind our emails. This is a picture of Lucian Perișoară's laboratory. He will talk about later to you. And again, again, our emails. Please feel free to contact us to talk more about E-PiCo here in Romania. Thank you.
Okay, thank you, Octaviana, for this clear presentation. Okay, so I don't know if Dan want to say some words or not. So
unfortunately, Professor Stoichescu cannot attend today because he is catched up with the evaluation procedure here in Bucharest.
Okay, so no problem.
So thank you.
Yeah, thank you for this presentation. So I think now Thomas from Kiel University will present the Master Kiel side at 9:45. Ah, okay.
I can do it now.
Here. Ah, you can do it. Okay.
Just need to
very well
change my camera. Hold on a second. So here we go. All right, so I think that you can see my video. So thank you for giving me this opportunity to present our university this morning, and welcome everybody. It's a great pleasure to be here and give you some information and some background about Kiel. So my name is Thomas Maurer. I'm chair of the examination board, also program manager for E-PiCo at Kiel University, and my background is in automation and control engineering and theory. And just to give you a little bit of an overview, that's basically the city of Kiel, so kind of an aerial image. And you see we are located basically at the Baltic Sea, which starts here right at the top of the picture. The city more or less surrounds the Kiel Bay or fjord, depends a little bit how you pronounce that. And the main part of the city is basically here located on the left. We are located here on the right. So we are opposite to ThyssenKrupp Marine Systems, which is a very big company in shipbuilding and also submarine building here in Kiel. So you see that there is kind of lots of space also not only for working, but also for some leisure time that you can enjoy, in particular in the second semester that you spend here basically during the summertime. So let's continue a little bit concerning Kiel University. It was founded 1605. It's the only fully fledged university in Schleswig-Holstein. So Kiel is the capital of Schleswig-Holstein, which is the most northern federal state in Germany. We have about 27,000 students, about 2,000 scientists, and are organized in 8 faculties. There are currently 4 research areas or priority research areas, some motivated definitely by our, let's say, location here, which is, so this motivates, of course, to address marine science, but there is also life science, lots of life science activities, aside environmental and cultural change activities, and also non-surface and interface sciences. And I think that also energy is going to become subsequently one of the new priority research areas. We have 2 clusters of excellence here in Kiel, which is pretty high class, let's say, funding scheme from our government. And we also have 6 collaborative research centers. 2 of them are at our faculty of engineering. One is about sensor devices, so magnetic electronic sensors, and the other one is about, let's say, new computing paradigms, so-called neurotronics, where we basically try to mimic, let's say, brain dynamics and processing, or let's say processing features of the brain, and also embed them into technical devices. As I said, it's not only about work, but you might also enjoy the nearby beaches. There are lots of them, as you can see here. And there is also, despite COVID, there is lots of activities during summertime when the situation is hopefully going to relax, so they can also have some time to spend there. And I think the present students, they kind of enjoy that. So for E-PiCo, let me just give you some background information why we are also interested and active here in E-PiCo. So the study program addresses some very highly relevant theme of sustainable mobility of the future that's relevant for the region, because Schleswig-Holstein is one of the national pioneers in renewable energy production, and hence integrates excellently in our local industrial as also research environment. As I said, energy will probably become a new research focus of Kiel University. And we are here able actually to bundle the relevant knowledge from power electronics, automation, control, and different aspects of that. We also have received very positive feedback from the current students. This means from the current E-PiCo students, but also from our students in the regular electrical engineering study or master programs. They also basically find this very attractive. And it also strengthens our research activities in e-mobility. For example, in different projects, I will pick out one, which is called Captain Kiel, but there are other projects that probably Marco LISERRE is going to talk about subsequently. So let me pick out this Captain Kiel project. That's kind of a very visionary project about clean autonomous public transport. It says here in Kiel, but of course the idea is to basically project that also to different other cities where we have an interface between road-driven or land-based transportation and sea-based transportation. And we have a ferry operation, we have, of course, public transport, and we would like to better interconnect them and also combine these with clean technology. Also, autonomy is something that is a highly relevant topic here for buses, but also in particular for vessels, as you see up there in this design study from a design university in Kiel. And there's kind of an interface between different, let's say, public partners, industrial partners, and also university partners. And we are defining a bunch of research projects that are also very interesting for US E-PiCo students. Just very briefly, you will have the opportunity to go to Kiel in the second semester. Here we basically govern different modules addressing power electronics, nonlinear control, and also electric drives, plus a bunch of elective modules that you may choose from. And if you spend the third semester here, we basically offer you 2 directions. I'm responsible for the area which is about, let's say, complex dynamical systems and their control, where we're looking at different topics from optimization to mathematical modeling, and also advanced control concepts, plus their experimental evaluation and implementation. And the second branch is about power electronics and drives technologies, which Marco LISERRE is responsible for. And as you see, this is more about electronic converters, intensifying the activities in power electronics, also including a lab plus elective modules. Just very brief, because I think this is much more interesting later on if you arrive here in Kiel, or when you arrive here in Kiel. Also, if you come here, you will see that all our faculty is actually undergoing large construction work. This is due to the fact that we will get, first of all, a new lecture building that is currently under construction, and we also get a Center for Networked Sensor Systems, which is also a new, let's say, research building that are going to be, both are going to be built in the next 2 years. So constructions have already started. And they, as I said, they will go on for the next 2 years, I assume. But then I think the campus is going to really gain a lot, and we are very much looking forward to that. Just as a last slide, the team here at Kiel. So besides me, that's Marco LISERRE, who is also going to give a presentation. He's the vice chair also of the examination board. Our local coordinator is Dr. Kristin Scholz. You might have already been in touch with her if you have some administrative questions, and she's supported by Felix Heute, who is the organization assistant. We also have a website where you also find our email addresses there, or otherwise just look on the web. And we are, of course, available all the time, and we're also very looking forward very much to welcome you then in Kiel. Thanks.
Okay, thank you, Thomas, for this kind presentation. Okay, so before going to the next talk of this first day of the winter school, I don't know if some students or another person have questions. Yeah, if you have any questions, don't hesitate to ask them to us. Okay, so now we will switch to the next presentation. So this presentation will be given by Professor Marco LISERRE from University of Kiel. As you can see here. And it will be about chair of power electronics, and the head of this chair is Professor Marco LISERRE. So I don't know if Marco is connected now. Marco, are you here? I don't think so. So we'll wait for some minutes, few minutes. We'll wait until Marco will be connected and start this presentation. So maybe if you have last question. till Marco will be connected. Okay, so as you can see here, so at 11 of this morning, so we'll have a presentation from HiPeRT-Lab. HiPeRT-Lab is the lab working on high performance real-time between academic and startups. So this talk will be given by Paolo BURGIO from Italy. So then we'll have a break here for lunch, and on the afternoon, at the beginning of the afternoon, so we'll have a presentation from Daimler, Mercedes-Benz, about poor battery electric vehicle, HV electric systems, which will be done by Urs Baum from Daimler. And the second presentation of the afternoon will be done at 3 p.m. by Hussein Alatar, who is the PhD student on the chair at Central Nantes that I lead, between Renault and Central Nantes, about electric vehicle improvement performances of EVs and HEVs. And it will be about electrical vehicle charger control in V2G and G2V, vehicle to grid and grid to vehicle, or what it is conventional to usual to say vehicle to X. X can be grid, can be load in general. Okay, so he's my PhD student. Okay, so we are. I don't know if Marco now is connected or not, so I will check this. Ah, Marco is here. Okay.
Hello.
Hello.
Hello, everybody. Hello, Malek.
Yeah. Good. So I think you have the rights to share your screen.
Yeah.
You can check this.
Yes, absolutely.
And you can start if you are ready.
Oh, what is the problem?
I will.
Okay. Sorry. Yes, now I understand. Very good. Just 1 second that I put in full screen mode again. Moment. 1 moment again. Sorry. Yes. You have to fight it always with the multiple screen and
yeah.
So now, but then we lose again the full screen mode. I don't know why. Okay, now you have the full screen mode, right?
Yeah, right.
Okay, very good. Let me make this other window smaller. So first of all, I'm very happy to meet with you. I mean, we had already 1 year a very good experience with the students of E-PiCo that did come the past semester. the past 2 semesters. So it was very nice exchange, and so also we had together also see a little bit. The city of Kiel. Oh, just 1 second. Right. Okay, good. Now I will try to don't make any error anymore. So yeah, it's a little bit the story of myself. I was professor in Italy, in Bari, which is a technical university. And then I was professor of reliable power electronics in Aalborg University. And I'm in Kiel from almost 10 years, we can say. And I find me in Kiel very well. And I think you also, if you come to visit Kiel, you will see that it's a nice place to live. And also we have good infrastructure. And for that reason, even if I got offered to be professor at 3 technical universities in Germany, Ilmenau, which is the top technical university east of Germany, TU Hamburg, which is our neighbor here near Schleswig-Holstein, and Munich, I have not to say because I think you know it very well, this university. Also very nice condition there, but I decided to stay here. And Kiel University did propose me to start a research center with the Fraunhofer ISIT, which we have in the region, which is also something unique that we have in this region, is the Fraunhofer Institute for Microelectronics. And among the other things, we have also power electronics there. They develop semiconductor based also on GaN technology, and also battery cell based on silicon anodes. And then the Fraunhofer ISIT, which is in Itzehoe, which is 1 hour car from here, and Kiel University were already cooperating, but the idea is to make it stronger, the cooperation. And in Kiel, we want to open a co-institute of this Fraunhofer ISIT. So we get some funding for this initiative we call ISIT at CAU. So because the Fraunhofer ISIT is coming at CAU, we will have rooms, we have research and so on. And I will be deputy director of Fraunhofer ISIT. So together with the director, Axel Müller-Gloring, which is also professor at the University of Kiel, and the other deputy director, which is Holger Kappels, which is also professor at Kiel University, is about power semiconductor. We will lead this institute. I say that among the 3, I'm the person which is most strongly connected to Kiel University, stay most of the time at the Kiel University, and they are more at Fraunhofer ISIT. So my background is, so my history is I did start my career about power electronic converter in the electric grid, which is now the major topic. And I wrote also a book about that, which is quite well used, not only in academia, but a lot also in companies. So I'm quite happy to hear when it's come to meeting some company like SMA in the solar field. They say, yes, we know you because of this book. This book is also used for some of the courses that we have here in Kiel. And I've been working quite strongly in power converter connected to the grid, and then also in reliability, which is my second strong topic from 10 years. And recently so my team did start strongly to work also in power semiconductors, so new power semiconductor like one band gap devices for also the field of smart grid, of electric vehicles. And I would say that the team here in Kiel will also enlarge itself. We have a new professor in power electronics for electromobility, and also the colleagues of material science. We cooperate with them as I said, we're doing also batteries. Now we'll also go a direction of passive component for power electronics. They will have also new professor about energy materials. So we are building strongly our let's say team, and not only the team, but in general the faculty and the university is strongly investing in the field of energy, using also a lot of this synergy with the colleagues in material science. So we'll still do control, and so we have a good also reason to have link also with other partners in this E-PiCo, which they are focusing on control, but I say we will try to take the innovation in the field of materials and bring them to power electronic products. So if you see the actual team that I have now, but as I said, this will grow because as a consequence of this initiative. I have a senior chair assistant, Dr. Langwasser, which is also strongly in the field of electric grid application of power electronics. And then I have other 4 senior assistants and 2 technicians, 3 secretaries. We will have 4 soon. And there are these groups that they are focusing on control and reliability, power converters, electric grid application, and batteries. So that are the main field of research. I say we have quite good laboratories. The laboratory power electronics is we build a prototype based on silicon carbide and gallium nitride semiconductor. We can do the thermal analysis of semiconductor. We are able to also develop by ourselves drivers for this new semiconductor, and we try to look to new topologies for having higher efficiency into the management, especially of DC, because DC is a very hot topic in the renewables charging station, also onboard electric vehicles, in general electric transportation. And I mean, you should consider it, especially for transportation, using an high frequency transformer, which is in the core of this DC-DC converter, lead to a significant reduction of the size and weight of a power converter. So you can significantly reduce the size of a system if instead of a transformer at 50 Hertz, you have a transformer at high frequency. And this is a very hot topic because it not only reduce the space, but use less copper and less iron. And you should know that especially copper is very intensive so it creates a lot of CO2 emission, and it's also limited in nature. So I mean, we have no way, if we want to in the future still develop our electrical system, to go high frequency for the isolation and voltage adaptation. And then we need power electronics. So it's a good news if for power electronic people. That is one example, I say, of the laboratory, but it's also another medium voltage laboratory, which is brand new. We have the possibility to make a test up to 1 megawatt, 10 kilovolt. We have 3 cells. And in each of the cells, we can build a different prototype. And so charging station is a very important topic here. High power charging station, we are focusing a lot on that. And this is, for example, showing what we have in the single cell. In one first cell, we have the modular multi-level converter, which will be make it ready in the next 2 years and go in the field to connect a wind park. In the cell 2, we have a charging station based on silicon carbide. And in the cell 3, we have also another high power multi-level converter. So if you have heard about this topic, you have interest, I mean, you can come here and make nice experiments with these devices. And then we have also focusing a lot, let's say, on thermal analysis of power semiconductor, especially in automotive application. They are subjected to very demanding conditions. So we use optical fibers for analysis the temperature of the power modules. We also use the infrared camera to make this analysis of the temperature. And we have a very good relation with both the companies like OpSense is a Canadian company and Infratech, which they make the two devices to make the analysis, but also with companies that produce power modules like Danfoss Silicon Power, which is in the region, and produce a capacitor like MERS and FT-Cap. So I think this is also, there is some good reason to do that. We also make a lot of microgrid research. Here, this is a unique setup where you have several power converters which are connected in a network. And we can test really realistic grid condition. We have also, you might heard about smart transformer, which is a flagship topic of our chair, which can be used also as a charging station. And this is in the laboratory, we have the possibility to build an hybrid grid, AC and DC, with different kind of storage and test different control approaches for the power flow. And then this brand new laboratory energy conversion, where we basically focus on considering the batteries. And we, here you see in this picture, apart from the president of the region, which is giving us the certificate of the funding of this laboratory, we get 2 million euro. There's also Dr. Sandra Hans, which is a researcher in material science and developed batteries. And the same things they do at the Fraunhofer ISIT. So this is quite nice because we do research with the people that develop the batteries together. So it's a very strong field. And also we build power converter based on GaN, on SiC, or both for onboard and offboard charging. Yeah. And then, so a little bit about the research. Again, our strong focus, as I say, there is this isolated DC-DC converter as a topic. Then we have a multi-level converter, which they are mostly used for let's say higher voltage, but multi-level is also taking a lot of place in automotive to create modular solution for integrate the batteries. There are some interesting concepts in which you use the same battery when it's not anymore suited for the auto. You can use at home, and so you can embed in the battery pack a power converter, which for the car can be a DC-DC converter in order to connect to the main, let's say, DC bus. And then when it's you will not use anymore in the car, but use at home, it can be creating an AC signal to connect to the AC grid. So you can create a very flexible power converter. Then, as I say, we focus a lot on reliability. You should know that this is a big challenge has been driven by the field of automotive. I was in Aalborg when it did come this strong push to go and to look more into the reliability of power converter, because it was noticed that many other fields, they made a significant step forward for having extremely high reliability standard, but power electronics was a little bit let's say lacking of this perspective. And the automotive is needs an extremely high reliability, because you can imagine if you build 100,000 autos and then one component is not reliable enough, the enormous cost it can be if you have to get back these autos to change this component. So it's very important to have a strong focus on reliability. And in Denmark at that time, all the strong companies that were also supplying components to our automotive industry, especially in Germany or in the field of renewables, they were pushing for that. And so we have done together this Center of Reliable Power Electronics in Denmark. And I'm still cooperating with the whole board, but also here in Kiel, I continue to do this research in my own team. And then we have focus about control of grid connected converter, which could be, for example, for interfacing a charging station to the grid and hybrid grid, as I told you previously. So related to teaching, we have a different kind of offers. So I would like to suggest you for sure to have a course of design of power electronic converter, which is about really the topologies of power converter. And then in winter, there is the modeling and control of power converters. And we have seminars in which you can take one topic and go in deep on that. And there's the possibility to make a power electronics laboratory to put hand on our system. And then we have offering courses about renewable energy system and grid converters for renewables. And also electric drive, microprocessor. And in winter, we are now offering also a seminar course about batteries where we make some lecture. So Professor Moira team also about modeling and control of batteries, my team about more power electronics, and then people, as I say, of material science, of other university in the region, they are teaching about the battery technology. And this course had a very high appreciation from students, despite we organized it this year a little bit in a hurry, but I think the feedback was quite good. I have not to tell, of course, about the E-PiCo. We are also doing a PhD course. We were doing that now when Corona will allow us. We will start again. We did until 2020. We have several projects at European level, national level, local level about integration into the grid of renewables, charging station, also a local project like HillFlex. We see the mobility in the city, for example, in ships, because we have an harbor, and so there are coming a lot of ships or buses, which they have pantograph and charging station. We look at all together this let's say this aspect. And also on the mobility, we have electromobility. We have a project about charging station with the silicon carbide, and how to protect this. This is DSTS project. So because these devices, they are reaching extremely fast. We have also a lot about wireless charging. As I say, we have something about the batteries for sure. And then we have also a priority program for the German Research Foundation about the use of GaN with the Aachen University. They investigated there the semiconductor. So we have quite significant activities there. Yeah, a little bit of statistic about the staff. You see the staff in 2021. I think in the next 3 years, we come for sure to 40 researchers in our team, and also scientific publication. We are a group which cooperates strongly with industry, but we publish a lot. This is a little bit about our fundraising and this initiative, EasyTat-CAU, which is with the cooperation with Fraunhofer. EasyTat will increase significantly also the number of funding and will make our group significantly larger. This is a little bit about the overall statistic of the teams. We also do patents, 4 of them with company, 2 of them have been granted. We have several industry and academic partners, and and also this number of students. We are also increasing them thanks to all of you that are coming to Kiel for this master E-PiCo. So we will be happy to host you. I mean, the message is also that at the moment we have not so many students that we cannot follow the student. They come very closely, so we can follow you very, very closely if you come to Kiel and work in our teams, because we have a good number of researchers, so almost double researcher as the number of master students that we have. This is a little bit what I told you previously about a strategic view. So we want to focus on power electronics, considering the aspect of the materials to produce the component and be aware of this waste of energy and water to produce them, and to make power electronic more compact, more efficient, and more reliable. And also we would like to make this system reparable, because we don't want to have the case that when a component is broken, then you have to throw out the entire electronic system. So it's a trend also in the European community to avoid the electronic waste, which I think it makes a lot of sense. And then for that reason, I talk about Unify, to put together this new material also with the control approaches, which we are working a lot, and come to bring power electronics to the new level of integration. Yeah, it's a little bit about this initiative, new electronic energy system from OFAIS, it's what I call the EasyTat-CAU, where for the now we focus on two topics. One, the so-called electronic grid, so electric grid dominated by power converter, and the other one, active reliability, which is very strongly interested in the field of automotive. We have currently a large contract with the industry to develop and bring this topic into the automotive. So how you can use control to increase the lifetime of power electronic components. Very, very appealing, because having a possibility to use the control not only to control the speed and the torque, but really influence the lifetime of the component which are used into the system. And then we are organizing a conference which is called PEDGE, the Power Electronic for Distributed Generation System, which will be held this summer in June. So there will come a number of researchers in power electronics, and they will basically, we expect 200 participants, will be hybrid form, partly will come in person, other will be remotely, and we'll discuss about power electronic system in the electric grid, but this also include charging station and this kind of topics. And in 2025, we will even have a larger event, the Power Tech, which is a conference which we spent 500, 600 people. So, I mean, it's also good to have the possibility to hear the last advancement in the field of power electronics. Yes, and that's from my side. It is all. I mean, for the first presentation, I have some more specific slide on single concept, on single projects. So, I mean, if any of you would like to put some question about on a specific topic, I can continue on giving more details on that topic rather than speaking continuously, let's say, in the open loop. So I would like really to have a feedback from you, and you can put question to this presentation, or you can ask to get more information about others. Yeah.
Okay, thank you, Marco, for this nice presentation, the first nice presentation, let's say. So as said by Marco, if you have any questions.
Yes,
yeah, Rodrigo. We don't hear you.
Oh.
You can put your microphone on. No?
To be on, do you hear me?
It's okay now. We hear you.
Regarding the students that are going just one semester to Kiel and are interested in batteries management system, what are your recommendations, Marco? Or maybe for the students that are going to be 1 year also?
I mean, we have this course that it is in the actual semester, in the winter semester, about the battery. And in the next semester, we have the course about renewable energy system, which we also talk about the batteries more from a system level point of view. I would say that the winter semester is interesting because you get something about battery technology, battery material management system, and so on. And then there is the course about grid connected converters for battery, where you basically study, let's say, the topic of power converters, which they are connected to the grid, for example, a charging station. Okay, in the semester, summer semester, we have renewable energy system, which we see at system level, how battery they are used, design of power electronic converter, in which we focus on the DC converter, isolated DC converter, which they are the central point of a battery charger, and then I would say, yeah, that's it, the main things related to the battery that we can offer.
Thank you very much.
You're welcome.
Okay, another questions? Thank you, Rodrigo, yeah, for this question. And the answer from Marco, so we have time for maybe another questions if
professors, can you hear me? I have questions. I've checked the in the handbook for our third semester. There is an optional course called image-based 3D scene reconstruction. Is there any research based on this course?
Oh, sorry, I'm not sure to have understood you. You are in Hamburg?
No.
No.
I mean, I checked the handbook. The handbook.
Handbook. Okay, handbook.
Oh, yes.
Okay, sorry. I misunderstood. And okay, look in the handbook.
Yeah, there is a lecture.
Yeah.
About image and
yes.
Signal processing systems.
Yeah, I mean, we have considered a strong research group in signal processing system, which is led by Professor Schmidt. It's not in the main courses which they are offered in this master E-PiCo, but I think if you want to go there in deep, you can do. So you can look at Professor Schmidt web pages, the DSS group, the Digital Signal System group. Yeah.
But this lecture, yeah, just maybe to clarify this point, Marco.
Yeah.
Also, Thomas. This lecture is optional, right? Because you have two tracks. One track dedicated more for control, and another one more dedicated to power electronics.
Yeah.
Yeah, and this lecture is optional, so you have to check this if you want to follow it or not.
I mean, what I can tell is that you can, if you want to find more in this field, you can. It's not in the main core, but you can for sure.
Oh, okay. Thank you.
Hello.
Yeah.
Yeah. I have a question.
Yes, of course.
Yep.
Yeah. So, like right now, Professor, you mentioned that we are working on projects for the smart grids like Kiel Flex.
Yeah.
So, like I have my third and the fourth semester both in Kiel. So, like in fourth semester, will I also have a chance to work on these projects with the for internship something, or it would be just in the university, or we can work on the project with the city government or the city associations for the same?
I mean, so I think it's possible to, if we try during the courses to present always our project, our research activity. And as I say, we have not so many students that you have problem to come and talk with us directly. If you if you come to me or to one of the postdoc and assistant, they say, okay, I find this topic extremely interesting. I would like to do something there, maybe also a little bit in cooperation with the city. We can create this link. There is absolutely, because we are in the project together. So it is, we are open to encourage the students to go in the companies and so on. Or sometimes offer also the possibility to make the thesis at the chair, but in strong cooperation with the company, because I mean, it's also important that you get during the thesis enough input and enough supervision. That is very, very important. So that is, so also a message is that I don't suggest you to go by yourself and apply for thesis in the company without following first of all, looking for the connection to the research group if you want to do the thesis in Kiel, because this is how we do here. So we do that is through the research group that we create a connection. We discuss with the company about the topic. We look for having a topic which should be also interesting for you, not just doing and making some labor work sometime for company. Yeah.
Got it. Thank you.
Good. Okay, we have still time for questions.
Hi, Professor Marco.
Yeah.
Hi, I would like to ask about the new battery technologies and materials. Is there something new that you would like to highlight about the new findings about battery material?
Yeah.
That could
I can show you something. As I say, it is absolutely. Let me find it. Now you see still my presentation, right?
Yes.
Yes.
Okay. I mean, this is a little bit showing the energy density of the different kind of battery. So at Kiel University, they work a lot on technology. Okay, lithium, as you see, is dominating because it's extremely reactive. So, but also.
Sorry, Professor. I think we cannot see the.
Not anymore.
No, what you're showing about the density. We are just seeing the current presentation about the chair of power electronics at the.
Let me share again.
Okay.
Now?
Yes. Perfect.
Okay. So it's about the energy density, and you see that lithium is everywhere because it's very reactive. Apart, I mean, the classical batteries. And then you have that the sulfur is extremely appealing. Because also sulfur is it's a good material too, and also can be found quite well into the nature, so it's not so limited. And for the cathode, but for the anode, also silicium is extremely appealing. And then the push for high energy density, especially for the, for example, electric flight, could be interesting. And then the nice thing is that here at the University of Kiel and the Fraunhofer, there are two different groups, very strong. They are looking about the processes that they actually create a problem into when the battery is charged and discharged that could lead to the battery to change its volume and to create mechanical stress. And so they have some approaches, this thermal coating, to basically keep the capacity at each of the temperature extremely high. So that is, and this is because they use these nanoparticles. We have a laboratory about a nano laboratory here. It is a small campus here, so this good thing we are all close together. There is a research association here of different professors in different fields, and also people from industry, which is called KINSYS. And then they already do these things within this laboratory, want to do even more in the field of energy together. And this is showing a little bit, this will be told in the lecture, but a lot of challenges for sulfur anodes, and they are working currently to solve these challenges, because sulfur is basically an electrical insulator, and then you have to make it somehow conductive. So this is one of the main things. But good things that then we work on the charging strategies for this kind of battery. So studying the modeling of the battery, and this is the impedance spectroscopy, which we can do here in Kiel, and also, as I say, in Fraunhofer Institute. And then we try to develop strategies with some pulse charging to try to improve the behavior of this battery. You can try even to counteract the aging of the battery, because they have this strong push to charge faster the battery, but that is affecting the lifetime of the battery. And then it's coming power electronic, because with the charger you can shape the current which is coming into the battery, and then try to counteract these processes. So I think that is a nice challenge, because it comes a lot of different knowledge together. Material science of the battery, then it comes about modeling and identification of the battery with control. Then we have power electronic, because it's the battery charger which should provide this current. So this is a quite interdisciplinary field. Yeah. Do you have some question? I want to just to give, let's say, a little bit about that, but I'll say if you come, you can even hear more about that.
No, it's really interesting. And have you applied this battery like in? I can see that you applied some current curves to simulate charge and discharge, but there are some tests to simulate like this battery would be used in an electrical vehicle, for instance.
Yeah, I mean, that absolutely. I mean, it's you should know that. So, for example, Fraunhofer is strongly connected to Volkswagen, for example, with the other partner. They develop also specific tailored batteries for them. We do in our laboratory a concept like similar like a digital twins idea, so that we try to characterize and the battery cell to get then a software version of that, and then we can try to our power converter to obtain the optimal charging strategy before on the emulated battery and then on the real one. So that is absolutely, it happens at different levels. So from most advanced into the laboratory to more consolidated technology close to companies.
Okay, thank you very much, Professor.
You're welcome.
Okay, thank you for this nice discussion about battery issues and their use on EVs, HEVs. So if you have another questions, we have still time to discuss more about the issues.
Hello, Professor Marco.
Yep.
Yeah, this is Abid Hassan. I'm supposed to do my third semester and fourth semester at University of Kiel.
Yep.
So basically, my question is about to clear a confusions that we have among our groups, that if I want to intend or if I want to do my thesis in a company, should I approach to the company first or to the professors at Kiel?
No,
So
professor first. Professor
Sorry?
first. We told you. We told professor first. So I mean, in Germany, is working that you talk with the research group first and say, I would like to have this preference, this topic. Also, I mean, if you are aware that there are some opening for taste in the company, it could be also fine. But you discuss with us, and then we talk together. We can come with also other proposals. Say, okay, there is this other company which we are cooperating with, and they propose this topic and so on. Or we approach the company and so on, but not go to the company first, to the research group. Both for me and the Professor Moira, it works in the same way, and in general for almost research group in Germany is working this way.
Okay, so clear, crystal clear. Thank you.
Okay.
So our so focus is to guarantee for you the best possible solution in order to grow and use the thesis really as a factor to increase your knowledge. Either, and this is not making a very strong difference if you make directly at university or at in the company. It's important that we try to do so that you get a topic which is not something that maybe is just used for I don't know, building a setup. I mean, we also pay students for building setup, it's clear, but we don't offer that as a topic for a thesis, because you have to grow. But that is the main, because industry in Germany in this field is extremely looking for people, but it needs competent people. So you have to build competencies. That is the main message in the right directions.
Okay, so thank you so much for the information.
Okay, good. Thank you all for these questions, and thank you, Marco, for the answers. Marco, I ask you a question. What time you need for the second presentation? How many times?
Sorry, which was the second presentation? Sorry, because
you will give the second presentation or not?
No, that was my presentation. Sorry.
Okay,
okay, so that was my idea, because I think we have 1 hour approximately. So I think we are
exactly.
Yeah.
It's very important to give time for questions. And,
exactly. I mean, I thought to present the group, present some topics, and as it happens with one student asked more about battery, I can say more batteries. Some of the students want to ask, I can go in deep in another topic, whatever. It's a hybrid grid, modular multi. I mean, we have time until 11, right?
Yeah, until 11,
exactly.
Of course,
so if any of the students want to get more on one topic, I can use 10 minutes from this other topic, and then I can answer question on this topic.
Yeah, good. So we have 10 minutes, maybe half hour. No, quarter hour. Okay, 15 minutes to start the next presentation. And I see on the chat one question from okay, just to see this, because there is some questions asked on the chat on YouTube by students applying for E-PiCo.
I cannot see.
Is there any preference for candidates with field experience? Of course, to apply to E-PiCo Master, you need to have some experience, background within the field of the master, of course. So the first point is related to electrical engineering and automatic control. So you have to show that during your bachelor you have studied these topics. it's very important to be enrolled on the E-PiCo master. And what are the other questions on the chat? Okay. Yeah, if I graduated my MSc in control systems and I already applied to the E-PiCo program, is there any other option from the consortium universities for PhD or MSc if in case I don't win for my application? Yeah, so it is important to know that also in the fourth institutions, we have local MSc, local master, so you can apply for this local master with, of course, there is no scholarship, but you can apply with self-funded option, okay? And the applications with self-funded will be open, I think, in 1 month. So these applications would be open next. You can check the information on the website of the master, of the E-PiCo master. And of course, yeah, we already propose PhD subjects in the field. Yeah, so there is also possibility for PhD subject, but you have to show that you already had master research degree before applying for a PhD subject. And we will analyze it with your CV and so on. There is, of course, a possibility, but it depends on your studies on the field, your ranking, and so on. So in general, these PhD subjects are put on the website of each institution, research laboratories of each institution. So you have to check this on the websites of the research laboratories of each institution to see the different PhD subjects proposed by these different institutions. Okay, if there are another questions. Okay. So I don't know if now Paolo BURGIO is connected.
Hello, can you hear me?
Yeah, we hear you.
Okay, yeah, I connected.
Okay.
100% connected.
Okay.
So
good.
shall we start before? It's
Anyway, I say hello to all the students, and I'm looking forward to interact with you. And I'll be always naturally very happy if some cooperation are created within this consortium with Malek and also the other colleagues from Italy and Romania. So see you soon, and we hope to see you personally very, very soon.
Thank you, Marco.
Okay. Thank you.
Thank you.
Bye-bye. Bye.
Bye. Okay, thank you, Paolo BURGIO, for coming and give the talk during this winter school.
Thank you for the invitation. It's nice to be here.
Okay.
Shall I share, start, or?
Yeah, you can start to share your screen if possible.
Sure. Yes. Just let me know when you see that.
Yeah.
There we go. Is that okay?
Yeah, it's okay.
Perfect. I only remove this. Okay, got here. Okay, so first of all, I can speak even for 2 hours in a row. So feel free to interrupt me or let me know 5 minutes before whether I'm going too much. I think I have 1 hour and a half slot. Is that true?
Yeah, 1 hour with questions. So
1 hour with questions.
Yeah, if you can do the presentation during
yeah, no problem.
half or 40 minutes, half hour or 40 minutes, it would be good.
What do you mean? Sorry, 14 minutes plus.
Yeah, 40. Yeah, 40 or 30 minutes.
And plus questions.
Yeah, and the other remaining time for questions.
Yeah, I will do my best. And this is also, I'm asking to all the students and the people listening, I will go quickly through a lot of stuff, but feel free to interrupt me. Okay, this is not a technical presentation. This is something that is more, I'm showing you what we do, and it's about autonomous driving. It's less related to electrical vehicles. That fits perfectly also with electrical vehicles, of course, but feel free to interrupt me, okay?
Okay, thank you.
So first of all, let me introduce myself. I'm a software guy. I'm an assistant professor at the University of Modena and Reggio Emilia, but which is maybe interesting for you, I did my PhD at the University in Lorient, which is not far away from Nantes, I guess, if I remember well, because I was studying also at the University of Bologna at the same time, and this multidisciplinarity was really important for me. It gave me a lot of, it made me richer, you know, as a scientist and as a person. And this also, you will see also in this presentation and in my job, that is really important. Then I was born in 1981, and I'm old, I know, but since most of the guys here that are as old as me, I had a dream. So I don't know if you all know this car, but this car was my dream, okay, during the 80s. I don't know how many of you know this guy and this car. It's called KIT Supercar. It was a TV series. And yeah, right now, I can say we are ready to build it. I mean, we bought this exact car. So I think right now, after we build this car, I think I will simply quit my job because I don't know what else can I do after doing this. Okay, what's the goal here? It's to build, what we do is we build autonomous driving cars and drones. Cars are more fascinating because they are really a mix of multiple disciplines. So we have a lot of informatics, we have a lot of electronics, we have control theory, as you will see. We have mechanics, but we also have economics, optimization theory, because every cube millimeter or centimeter in the car is studied. And even if you open the car and you see a void space, it's not because there is nothing to put in there. It's meant to be void. It's meant to be empty space. So it's really important. And you really need a big team to work on a car. That's why you will see my presentation will cover a lot of topics, but it's not all done by myself. You will need a team to do such a complex stuff. And you will actually, this is my team, my at the University of Modena and Reggio Emilia, and we also have a spin-off, which is called the HiPeRT. And not many people know the big picture, but all of us are expert in a given part of the car or of the project. So this is, again, probably your professors already told you how much important is team working? Well, team working is everything. If you don't have a good team, you can simply drop the project because you will never complete. Okay. And then you see also two of our prototypes, actually four, because there is also the drone and the scale prototypes. The one on the right, the Maserati Quattro Porte, is our autonomous prototype. I know we are lucky. We are in Modena, so the closest car maker are Maserati and Ferrari. So we are really lucky that we could work on such a beautiful, beautiful vehicles. So what is a self-driving car? It's a car that can sense the environment and moving safely within it, taking decisions with no human input or little human input. What does this mean? That you need to accomplish a very, very complex task, which is interpreting the world around you. Okay, maybe you heard, and maybe you are tech lovers, and you know what Tesla is doing, you know what everybody who is doing an autonomous driving car is doing. Trust me. Okay, you have multiple sensors to read the world around you, to see what's going on, but it's not an easy task. Moravec said that it's easier for us to make a computer exhibiting adults level performance, like playing chess. I guess you know that computers already defeated human chess players since I don't know, 2 decades, 3 decades, I don't know how much, but it's nearly impossible to make a computer move like a 1-year-old kid. So this is the main problem, because actually our task that we do with the cars, the main task is the perception task. And it's really easy. It's for us humans. It's just watching around you and seeing objects and watching what's moving and what's still on the scene, and just move across the environment and localizing itself. I can bet that if I take any of you and you close your eyes, I bring you in your own place at your home, and you open your eyes, you immediately understand where you are. Well, that's not the case for a vehicle. So this is the big issue here. Then we are engineers, so we know how important is standardization. We have 5 levels of autonomous driving, okay, 6 levels. The level 5, what's called level 5, is the full autonomous at all. They increasingly specify not how the car is built, but how the degree of automation is shared between the car and the driver. So level 1 is little sharing, few functionalities on the car. Level 2 is a bit more functionalities, but some functionality is still in charge. The driver is still in charge of some functionalities, and so on. We currently are, for production systems, between level 1 and 2, level 2 and 2+, and the next level is level 3 and 4, which is really complex. It's a big step for technology. As said, level 0 are traditional cars, say grandma on the car. Level 1 is a vehicle assistance. So I guess most of you are already familiar with the cruise control and adaptive cruise control. What's cruise control and what is adaptive cruise control? Most of the vehicles already have cruise control, which is you simply set a speed and the car goes at that speed and regulates himself, accelerating and decelerating, not braking, but decelerating, so reducing the throttle to get that speed, that goal, which is a speed, target speed. This means that you give longitudinal control to the car. So level 1 means that the driver is capable, agrees in giving part of the control to the car. Again, it's not meant, it does not specify the standard how this is done. They don't care how you do that as soon as you reach this degree of sharing, you know. Adaptive cruise control is more or less the same thing, but it can even decelerate if the radar sees there is another vehicle in front of you. So it's not a target speed, it's a target speed plus not collision avoidance, but deceleration. Top class cars already have them, like Audi or even the Maserati have. This is another example, the assistance braking. What does this mean? That to avoid the crash, first, I mean, you're driving, you know, and you try to brake because you see that the car in front of you is too close, so you may smash into it. What the computer does, it detects that the braking is not enough. You are not braking enough, and you will crash into the car. You have to brake more, you know. So first of all, in a given distance, it gives you a buzzer. So it says, no, you brake more because otherwise you crash. And when you get close to the obstacle, to the other car, what I can do as a computer is I take control of the braking. So I push more force on the braking pedal, but please, so to avoid the crash. And maybe I tighten your seat belt just to prepare yourself for the crash in case, in the very worst case. Please note that the car is not taking initiatives here. It's taking initiatives, the autonomous system, but it's simply saying that you start the braking, the driver starts the braking. The driver pushes the brake pedal. And I simply adapt the force that you put on the braking pedal. So the decision of braking is in charge of the driver here. The amount of force that I put on the pedal is in charge of the automation, which is really important because I don't take initiatives. Lane centering, okay, this is quite, yeah, you know, it's quite trivial what you do when you want to do lane centering. So the car does not make you or makes the wheel vibrating when you cross a lane. Okay. Level 2, you have more than one feature, but still the driver is in control of the car. Level 3 and level 4, well, car starts becoming a co-pilot. So level 3, the car you can leave the full control to the car for a limited amount of time. Okay. So maybe let's imagine you are sharing, I don't know, you are on the highway, you want to answer to your phone, which I don't recommend now, of course, but maybe in the future you can answer to your phone. So you leave both the lateral and longitudinal control to the car for 10 seconds, 20 seconds, not much. Or maybe just for the phone call that you're doing. Level 4 means that you identify scenarios and the car is autonomous in this scenario. What do you mean? Let's say you go to the valet parking. You go to the valet parking is the main example. You go to the shopping mall, leave the car in an area, and the car autonomously drives in the parking. So the catch here is that the parking is a well-structured environment, and for instance, no humans are allowed to enter the parking. So it's very simple because if the car is autonomous, you can have only one car moving in the parking. There are no obstacles. Maybe there is, I don't know, a bird or a car or a dog, but it's safer than in a complex environments where you have humans walking here and there, you know? So this is L3, L4 autonomous system. And L5, of course, is fully autonomous cars, but we are far away from that. And I will show you why. Let me go a bit on the technical part. How do we do autonomous driving in Unimore, in Modena? There are multiple ways of doing so. This is the way we do that, which is the mostly common known way of most of the people around the world that do autonomous driving, they do what we do, or we do what they do, okay? Then there are some variants. For instance, you have Tesla that only works with cameras. They don't use LiDARs. So, but this is more or less, it all boils down to this approach. So you have 3 approaches: perception, planning, and actuation. So perception, as said, is sensing the environment. Planning is taking decisions. So saying, okay, I want to go from this point to that point. I want to do an emergency brake and so on. So this is the real brain of the car, I would say, the component that takes the decision of what to do. And then the actuation, because you can take a good decision, but if you don't have control of the vehicle, of course you're dead. And you want to do this, all of these 3 steps in a limited amount of time. You will see in a given amount of time, let's say my LiDAR has 4 Hertz or 60 Hertz 40 or 60 hertz, meaning that I need to compute LiDAR frames or camera frames 30, 40, 60 times per second. So I need to do my computation of these 3 stages, I would say 40, 60 times per second. If I fail, if I miss a LiDAR frame, if I miss a camera frame, I would take decision according to a scenario which is old, too old, that then this decision couldn't be any more valid, okay? Because you are simply watching data that is too far away in the past to take a good decision, okay? And also here you see our prototype, our 1/10 prototype, and I will show you, because of course you don't really go and prototype directly in the vehicle. You have multiple steps of prototyping. Okay, things are a bit more complex. So it's not only about perception, planning, and actuation or control. It's about also interacting with the environment. So you have sensors. So you need to gather data from multiple sensors. You need to localize yourself, because of course you don't only need to watch what's around you, but you have to understand where you are. Of course, because if you have your mission planning tells you I need to go to the shopping mall, so you have a city map where the shopping mall is. Well, you need to know which streets you are, of course. And this shall be done by sensors. Like GPS may not really be the key here. So of course, everyone thinks, okay, come on, I have the GPS, it's easier. Well, GPS is not as accurate as you might think it is, but still you may have help. VTV, you see this block here, means that you get information by other vehicles, or ETV, infrastructure to vehicle, means you get information by the city. So you can cooperatively work among vehicles and the smart cities to get the autonomous driving task accomplished. Okay, I'm not going much into details. I will just, of all these blocks, I will give you some hints and some food for thoughts. Okay, perception, as said, you need both to do environmental perception. So you need to understand what surrounds you, and you see on the right, for instance, you see the green boxes here. They are called bounding boxes of detected objects. Okay, I even detect what you see here is what the car sees with the LiDAR. You have even a tree, but a tree is not important for me because now I want to detect cars and pedestrians. So I need to distinguish between what is interesting for me, a car, a pedestrian, and what's not interesting for me, a tree, you know? And this is mainly done using artificial intelligence. I will go through this soon. Then you also need to identify yourself in a map, possibly at the sub-centimeter precision. You know that GPS, standard GPS, doesn't really go to this level of precision. You typically have a few meters error. In the best case, you are under a meter of error, referring to your real position, which is not enough for autonomous driving, because having a few meters error is the difference for your car between being in the middle of the street or being inside a shop, which is on the side of the street, okay? But yeah, we can enhance the perception collecting data from the city. So this is complex, but we have weapons to how to fight this battle, you know? This is, okay, I start from the end. This is what our car sees. This is not the best that we can do, but gives you a good idea of what you get when you do the task of perception. It is not a problem here, it's just the video slow, but you see that you watch around you, you have bounding boxes, red ones, for the other vehicles, but you see those boxes are flickering, and maybe you don't see exactly everything that happens. So you shall definitely, when you design a system such as this, start by a good perception block, because if you're blind, there is nothing you can do, okay? So we have sensors. So first of all, you have to choose your sensors. You have sensors that are exteroceptive, like they watch outside, like cameras, radars, LiDARs, and you have proprioceptive sensors, like you shall know which speed you are going at. You shall know, for instance, the degree of friction and the drift that you're doing. If you're going high speed, you need to know, because maybe if you drift, well, you want to know that, you know. And the first thing that engineers did when they started building autonomous systems is to exponentially grow the number of the sensors that a vehicle shall have. Okay. Typically, cars only 20 years ago, cars only had maybe one radar and few proximity sensors that were mainly for supporting car parkings. Now cars have cameras, a lot of radars. They are shipping LIDARs, IMUs, inertial movement, inertial sensor, and GPS. So you have a lot of sensors now. Okay, this is our car. As said, we have 5 cameras, 6 cameras. It depends on the setup and on the specific project. We have a LiDAR, an hoster. We have GPS, we have radar, and we have multiple control units, meaning that for every project that we have, which are funded publicly by Europe or Italian government, we may switch to a different control unit. Okay. Let me give you the first food for thought, which is how do we do SEM? This means that if you look at the scheme, you do machine learning for object detection by the camera frames. So you detect object with a camera, and then you do clustering on the point cloud given by the LiDAR sensor. LiDAR is like a radar, but works with lights, okay? Laser lights. So why do we do sensor? Why are we sensing the world using 2 sensors? Because both of them have advantages and drawbacks. For instance, the camera detection is not really good at detecting distances as LiDAR is. But camera can detect the colors and LiDAR cannot detect the colors. So you want to take the best of both of them and to fuse them in a common view, 3D view possibly, of your environment. So you get the best of both sensors and you can increase them, adding the IMU, adding the radars, and you can even get data from the city. So objects that are detected by the city, you can use this information. You remap them in a common reference system, spatial reference system, and then you understand and you build a very accurate view of your surroundings. I'm not going much into this clustering. I will go through machine learning soon, but just to give you an idea, clustering is the technique where you get a point cloud from a LiDAR. So the LiDAR is like a radar, gives you a lot of points in space, and you need to cluster them according to their density. Intuitively, if you have now a cloud of points, but you can identify objects because in the regions where points are more dense than others, it's likely that there is an object. It's not really complicated to do from a mathematical viewpoint. Is a distance, the complexity is O3, I think, or yeah, O3. It's three-dimensional complexity, which is not, the algorithm itself is not complex to understand. The computational complexity is O3. So it's not really easy to do, but we have GPUs, come on, so we can tackle this. You can do localization again from the LiDAR. So you get, and this is a Monte Carlo method. It's called particle filter. I'm not going to the text. I will simply show you how it works. You see yourself in a map. Okay, I know I'm in a map. I'm somewhere here. I have a map, but I don't know where I am. So what I do, I generate 1,000 of random points in the map. Everyone is a candidate for my position. Then I say, what would I see if I were that point? So you generate for each of them the vision of the world that you would have, and you compare with the vision of the world that you actually have, okay? So this is, in the next slide, there is a short video that shows you will see red points. At the beginning, you have a lot of red points, which are the candidate position points. In green, I think you have your real position, so the reference. And you will see that increasing the iteration, as the number of iterations of the algorithm grows, the red points are discarded because you would not see, you discard the points which is not candidate for your position, and you finally get the real position. You see? The blue are the rays, so the view of the world that I have. The red are the candidate position points, and you see that I'm even more accurate, and I will end up understanding where I am exactly. Okay? This is the 2D LiDAR, which is only, we also have techniques for 3D LiDARs. The complexity, again, is quite high. So you need a GPU or some kind of high performance computer. Now, the vehicle, the drone localized itself. in a month. Okay, let's go back to the AI. Well, the AI, everyone likes artificial intelligence. It's like a buzzword today. And I don't know how many professors are here left yet, but yeah, I would say it's a very good way also to get funding, because you write AI or machine learning in some project proposal, and apparently people is really willing to fund you. So yeah, we like AI. It's not the killer, the solution for every problem in life, but yeah, it's very good. AI, it's basically, machine learning is basically a shift in a computing paradigm. Instead of relying on algorithms, as you said, the particle filter and the clustering, you build a computer that can learn. What do you mean? I'm not giving you an algorithm as a computer. I'm not giving you a steps to solve a problem in a finite amount of time. I'm simply teaching you how to learn. So I build the computer that learns. Then I send you to school. I send the computer to school. I give examples, and I make him work. This is effective. It works pretty well because it's an imitation of the brain, of course. And the brain, the human brain, it's actually, well, the reason why we are here is that our brain works pretty well. So I think it's a winning approach. Okay. What's the problem of AI, which is a first food for thought? Okay, this is how do we imitate the neural cells. On top you see a neuron which has dendrites, it has an axon and synapses. And how do a neuron work? The mathematical model of a neuron is quite simple. Multiple inputs, because every neuron in our body has multiple inputs, like signals, x1, x2, xn. And okay, I'm sorry, it is in Italian. Ingress, it's inputs. Pesi, it's weights. So you weight your signals. You can imagine every signal like a number. So you weight it, and the weight is given by the training. So once you are trained, you populate the weight for every neuron. Then you do a sum, and you get you reduce all the signals to a common number. If this number is lower than a threshold, soglia, on the bottom, see, then you trigger the uscita, the output. If this number is higher than a soglia, it's basically cuts the signals that are not too strong to trigger that neuron. And the output of the neuron, of course, goes to other neurons, and all the network works like that. This threshold is called funzione di attivazione, activation function. So you see actually the model is quite simple. It's like multiply, accumulate, which is something that computationally speaking is quite easy to do, but you have millions of neurons. So you need a highly parallel computer to do so. And it's a mathematical model. We all like mathematics, but the issue is that there are two guys here that are not simple: geometry, probability, algebra, statistics, and calculus. Well, I don't know if you see if anyone here can tell me who are the bad guys among these five. There are two bad guys in these five disciplines: geometry, probability, algebra, statistics, and calculus. I don't know if any one of you have the clue.
I'm guessing the first one is probability, but I don't know.
And statistics.
Probability and calculus.
You got it. Probability and statistics.
Yes.
What's the problem? It works. It works well, but it works 99.5% of the times. This means it fails one out of 200 times. This is not good. This is the problem, the main problem. Otherwise, without this problem, machine learning would be already on cars. Okay, so you need to build a system that monitors your machine learning. You know, and this is, I'm not opening the Pandora's box, but this is a huge problem. Okay, I guess now every one of you knows how machine learning works. You get data sets and you train cars. So those are our training sets. You see on the, I'm sorry for the definition. It's just a screenshot by our simulator or by our tools. So I'm really sorry for the definition of the poor definition of the images. So this is you need training sets. You need a lot of training sets to do so. And this is the reason why those guys here gather our data. But do you think Google really wants to build the car? No, Google, the business of Google is done with data. Of course, you can use data to build a car because you can use data to train a machine learning model. Okay, so this is the real reason why Google wants our data for the self-driving car project. They don't, this is one of the reasons. And we have an additional challenge here because we are in Europe, so we have GDPR, which is quite tight law for the privacy. And yeah, and this is, we need to collect, store, and manage this data according to privacy. Luckily, those 4 guys here don't have this issue because they are based in the US. But yeah, if you do this in Europe, you also have this problem. We do at Modena have this problem. Okay, let's go on. This is an old commercial by Pirelli. Now we have perception, and I'm going to something that is more probably familiar to you, which is control theory and planning. So we also have the problem of finding a path for doing something. So you have a global path planner. So I want to go to the shopping mall. So luckily I have all of those Google Maps, OpenStreetMaps that tell me exactly which is the path. So, okay, once I know where I am, I calculate the path to go there. And this I can do offline. I don't really need those small computers that we have on board. I may even have a server to do so. But then I'm driving, and maybe I have people crossing the streets. Maybe I need to brake because there is another car, which, I don't know, whatever. So you also need a local planner. So you need something that is more reactive and should be done online and fast. Our goal, let's say, again, 60 Hz. So you have to do this to be ready to do an emergency brake 60 times per second. Okay, so this is a kind of a big problem, but you can splitting this in 2 parts. It's really beneficial because the biggest computation you do in a global planner, which again, you can do offline. You turn your car on, you have seconds to do this computation. But planning, again, then you also have the behavioral planning because rules in Italy can be different by rules in France, actually not, but yeah, or to rules in Japan or to rules in the UK, because in Japan and UK you drive on the left. So the behavioral planner can be different, which is more, this is more tailored to specific rules for countries and streets. And then, of course, I tell you, local planner is on runtime, information available at runtime, okay? Then you have the control theory. So first of all, you need low-level, what I call low-level controls. So you need to control an acceleration, a braking, a steering. So let's say I give you an acceleration curve. I want to go from this acceleration, from this throttle to this throttle, and you have a PID, you have whatsoever that controls the acceleration curve, the braking curve, the pressure on the pedal, which is something which is more standard in control theory. I'm not going through this because it's, again, we still use PID controllers that are out there since 50 years. So I think there is not much to learn on this side. What's to learn is to do high-level control, meaning I get a path tracking, I have a trajectory tracking, I need to understand how I can follow this path. So I don't really need to control the curve of a braking, the signal of the curve of a throttle, but I need to work at a higher level and to go to drive the trajectory of the vehicle, which is already computed. The pure pursuit is the simplest quantum algorithm. It has only one parameter, which is a look ahead, and it's really, really simple. It's about computing, I think it's a cosine and an arctange or something like that. It works pretty well at low speeds. So if you go faster than 40, 50 kilometers per hour, it cannot be as accurate as it is. Okay. Then it produces the steering and signals. Typically, you produce the steering signal as a matter of degrees on the throttle, on the wheel, and the throttle brake signals as a speed or an acceleration. Okay. And then the low-level control takes care of actuating this high-level control. Well, when you want to do our core stuff, we have a Formula Indy car that goes 250 kilometers per hour autonomously. Well, this here, you definitely need to use some more complex control. The model predictive control is uses sample windows and a prediction horizon, and where you check if the output that you predict adheres with the trajectory that you already got in the past. So it's quite a complex one. I'm not going into details of that, but it's the state of the art currently for controlling autonomous vehicles at higher speeds, say more than 100 kilometers per hour. Note that the faster you go, there are many variants of MPC, but they all boil down of having an accurate model of the vehicle. The faster you go, the more accurate should be your module. So if you go 60 kilometers per hour, you can even have a bicycle model where you have two wheels, one front and one back wheel. So you don't have four wheels in your model, you only have two, and only the front wheel can steer. If you go to 100 kilometers per hour, well, I promise you definitely need frictions, you definitely need tire temperature, you definitely need the temperature of the ground. Because you start drifting, you have a lot of problems. So you need a very complex model, a very complex algorithm, which is based on this MPC framework. Model predictive control is MPC. And you have increased also the computational complexity. So you need more powerful computers to do so. And you want to do this in real time. So 60 times per second, 40 times per second, 100 times per second. So this is a big problem here. Optimizing this guy, I guess most of you are from the control theory, a student in the automation, so you shall know this, or you shall at least be confident with this. This is not easy. Okay, and we have a lot of work. We have PhD positions open on this. So originally it was supposed to take a break here, but I'm going faster because I thought I had 1 hour and a half, and then I realized that only you have 1 hour. So I will go on, and I will take, I would say, 10 minutes more, and then I leave room for questions. If you don't have any question now. Shall I go?
Hello,
yeah.
Paolo, this is Abid.
Hello, Abid.
Basically, I also have participated a similar course, which is being called Introduction to the Autonomous Vehicles, offered by the University of Toronto in Canada.
Mm-hmm.
And it's I have learned, thanks for these informative lectures from you, but I have some questions regarding to my past experience about using LiDARs and cameras, onboard cameras for path planning.
Yeah.
As you said, the global path planning and the local path planning, these two are associates to ensure for perfect destination for changing the destinations. So my question is, as you said, to compensate the drawbacks of LiDAR, we fuse the information of cameras on onboard from that coming from the cars. But the question is, as we are using if we use the machine learnings or algorithms for integration of the information of these two sensors, obviously we need very high computational power hardwares.
Yes.
So is it commercialized such hardwares in current vehicles?
Okay, let me show you the next slide.
Okay.
Okay, I will answer to you going on with the presentation.
Yes.
Okay.
Because I also have the same experience. In one project, I use a hybrid machine learning algorithms to fuse these two sensors. Yeah. And only by using these two sensors, LiDAR and camera, my kernel was crashed several times. And so I'm wondering, the current vehicles, which have at least 56 sensors, so obviously they are generating big data sets. So how do they actually manage to compute such big features to generate a particular output? This is my question.
Okay, I have multiple questions, answers for this. There is no common solution. The idea is that you don't want to rely anymore to what you see in this slide, which is putting high performance servers on board. We typically compute, our computer is big as a shoebox. These are embedded platforms, and you can have a lot of computational power on them. You may drain the battery with the most powerful of them. They are smaller than this, okay? They are more or less like this, okay? This was like explaining why we need the computational platforms. And then you typically have many core accelerators like embedded GPUs on FPGAs or ASICs. So nearly everyone that builds autonomous systems like Mobileye, Intel, or NVIDIA, or Tesla itself, they have a high performance embedded computing platform, which ranges from 30, 20 watts, 50 watts, 80 watts, and computes some teraflops. It's not a server, so you can't really do everything that you do on a server. Actually, that's my job. Whenever a guy with a very nice solution comes and say, okay, I have this new solution that works perfectly, this machine learning perception stuff. And I say, okay, but where do you run that? And say, okay, exactly. I run it on a server. And I say, okay, no, that's not the case. I don't have hundreds of watts in the vehicle.
Exactly.
I don't have all the space. Yeah, the idea is that, especially when you speak of machine learning, you can optimize the networks. So you may prune the network, you may quantize the networks and weights, working at lower precision, like you don't have floating point, 32 bits floating points, maybe you have 16 bits or 8 bits or integers. So you reduce the complexity of the network, you go faster, or then you are less accurate. So you need to tweak a bit the system. You can do it anyway.
Okay, in the previous lectures that I attended, they said the solution may be the cloud computing, but in that case, as I know that there is a canyon effect for autonomous vehicles. So if the canyon effect occurs, suppose there is a degradation of your signals, that your car is not capable to upload his data to the server. In such case, so it will be a disaster, in my opinion.
No, that's the problem. One of the solutions is to compute on cloud, but also, as you said, okay, disclaimer, we have a bias at my group and we are promoting as much as we can edge computing, okay? We trust in servers, but we want to push as much as we can to do computation on board. Exactly for the reason that you're saying, and additionally for the reason that you compute a lot of data, so you need time to send this data to the cloud. You have megabytes of data, 60 times per second. So, well, you shall have a very stable connection, okay? Anyway, it's partitioning the computation between the cloud and the edge computers. I will show you later. It's really, really research. So that's what we do.
Okay.
First of all, I would like to show you what you can do very quickly, because I treat autonomous driving as a game. So there are levels for increasingly become an autonomous driving engineer. So you start with simulators. So we use video games like GTA, Grand Theft Auto. We typically use that. Assetto Corsa, Carlo, LGWSL for simulating the environment. Then we have the board, the real board that goes on the vehicle, plugged to the simulator. So the computation is done on the board. So you have a first assessment of what your actual performance is, because you simulate the environment on a computer and then you have the algorithms running on the board. This is called hardware in the loop, and most of the designers do so. Then you have your algorithms written in Python, C++, or MATLAB. Well, of course, on board, we only want C++. So we typically, we deployed a C++ engine for machine learning, which translates network models from Python to machine learning to C++, and simply translating the neural network in C++ gives us 5 to 10 times speed up, because Python is an interpreted language, C++ is compiled. I will give you the details. It's completely free. It's let me check. This is guy here. This guy here is our neural network. It's GPL2, and you can download it and you can install it. It's a wrapper for C++ extensions of CUDA in NVIDIA. So you take a network, the description of a network, and then you make it run. You can quantize the network, and then we tested it on multiple boards. And this is what we typically do, okay? This is just to give you an example. After the simulation, you build a scale prototype. We will have in 3 months a race in Milan, so you're very welcome to join. We show you how to build the car, which is equal for every team, and then you work on the algorithms. For instance, in this car, we don't use machine learning. We have cameras, but we don't use them. because we realized that this board is so small that you can only use the LiDAR. For instance, this is, you have to try and fail, and then you take decisions. This is, again, is a race. It's a small car, so you're not really worried of smashing that, okay? Then you go to the real car, which is, this is called the Formula Students. Everyone can join the team. Everyone can join the competition. Is for students in universities. So you can set up a team in your university and join. So it's self-managed, the teams by this is MMR Driverless is our team in Modena, and the teams are self-managed. So us professors are just advisors. We don't really help the students in doing tech stuff. Then you join this team, you have 3 or 4 races per year, and then you miss probably 1 year of your CV, of your career, but then you have a very good CV. Okay, you build a full autonomous car in your university, and you participate to races. You need marketing, you need management. It's not only about tech stuff. It's having a real team. Okay, these are our teams. This is what we did. We were in Indianapolis with our car. This was the India Autonomous Challenge. This is our team, and this is the vehicle that goes up to 250 kilometers per hour autonomously. Support our team, so join the Instagram channel, okay? And these are most of them are our students. Okay, I will go to the city because we introduced the problem and of remote computation. So smart cities, this is the project that we have in Modena. It's called MASA, and it's a living lab for autonomous driving. Is a city, is an area in our city that enables testing these technologies. What you want to do, you can get data from the city, so you build training sets. So we also have research project only with the Department of Law, just to understand how to manage this data in a GDPR compliant manner. And then you can enhance the perception of the board. So what we do here, again, we can do computation on the cloud, but it's much more interesting to enhance the computation, enhance the view of the car, because thanks to the city cameras, we can, for instance, look behind the corner. So we can increase your view of the world inside the car. So if behind the corner we see a kid that is walking in the middle of the street, the car will simply brake and not turn, you know? Of course, you need city cameras, you have other vehicles, you have pedestrians with their smartphones providing information, you have connected traffic lights, connected traffic signs. So you have this internet of vehicles, which is really complex to manage at the cloud level. Then you have we have projects on digital twins, we have projects on cloud systems to process this huge amount of information and to deliver to the vehicles only the information which is required. So answering to your question, I may not even need to send data from the vehicle to the cloud and to give the elaboration back based on this data. I would send data to the cloud, and the cloud replies me with elaboration done on all the data of all the sensors in the city. This is even more challenging, you know. This is our platform. I'm not going to that. We can do computation on edge or in cloud. So of course, you typically do short-term sensing, predict and reacting. So emergency braking, you do on edge, on the car. Maybe on cloud, you do analytics, you do predictions and stuff like that. So because you have a higher latency, you know, and the comms, of course, shall be safe, reliable, and secure. This is a huge research area, especially in Italy, of course, but in Europe. This is what we do. This is an example of what we do. You have a city camera you have a city camera on the left. It does detection on the camera. So you transmit, the camera has a board. So you have around 50, 60 milliseconds. And then you transmit to the cloud only the metadata. You don't have to move all the data frame. You only transmit the detected objects. So their class and their position. And then you broadcast them on the edge. And we do that in 1/10 of a second, which is, I think, is a world record. Then you can even store this data in the cloud system. Then the city can learn offline and can build accurate models of traffic, accurate models, and so on. But the point is that you do detection on the camera, so you do it quite fast. and then you transmit only the metadata to the cars. Okay, so if you want to do an emergency braking because the camera sees a person, then you do it quite quickly, you know, like that. This is what we do now. Okay, you have cars speaking among them, you have cars speaking to the city, you have cars speaking to the traffic lights, so you have this distributed environment. I'm pretty much done. And you have a lot of stuff around the connected vehicle, so I'm not going much, but this is a huge world, okay? So there is room for everybody. There is room even for law, for ethics, for society, for technology, and stuff like that. Because now, who takes the insurance of an autonomous vehicle? Who pays for the insurance? I don't know. If you crash, whose fault? Of course, not of the driver. It's maybe fault of the computer, maybe fault of the LiDAR. So this is a big problem. A moral machine is something I recommend you to watch. But I'm done, so I hope I finished in time.
Thank you, Paolo, for this interesting presentation. Yeah, and for this exchange on the topic.
Thank you.
With our students applying for this E-PiCo master. If you have other questions.
Hello, sir. I have a question.
You have time? Yeah.
Yeah. So when we use a lot of sensors in the car, there is a chance for SCS, like system critical signals. So how do you manage the fault safe of this SCS?
Well, consider that every signal that goes through the car has a dedicated wiring. You may have even CAN controllers, but CAN is a time sharing protocol. So you need to redesign the car, the electrical system of the car, the EE architecture, electrical electronic, explicitly for autonomous driving. Because you may also want redundancy. You may also want to have 2 computers doing the same thing, or 3, which would be better. So what I know, because I work with car makers and tire ones, and I noticed that they are pushing a lot of effort, not mainly on algorithms, but on rebuilding the internal structure of a car. So putting more CAN controllers, putting more dedicated wirings, putting more safety blocks. This is the effort that they are doing. And this is the way to go, I think. Because software, they leave it to us, to scientists and computer science. And in academia, we do a lot of research on that. But the main effort is, again, to rebuild the car itself.
And I also have a question about the paradox. Like, what if there is a situation like what to decide is the best if there is 2 worst cases? So,
okay, let me turn your question. Yeah. This goes back to the moralmachine.net, which I told you. It's okay. Let's say there is a situation you're driving, and you cannot win. Either you smash into a kid, or you smash yourself into another car. So maybe you die, or the kid dies. Okay, there is no tertium non datur. Okay, would you buy a car that kills you?
Of course, no.
That's the problem. And this decision is hard-coded 3 years before by a guy like me in his office.
Okay.
That's the problem. Okay, you know, bad things happen. There are many situations where it's impossible not to kill anybody, especially in car crashes. There are situations where in a given point you realize, okay, either I die or the other person die, but there is no way to have everything safe, you know? And this is the problem. But because now I have a computer, so I have time to take a decision.
Yes, Professor, there is a new machine learning algorithm, which is being called the reinforcement learning algorithm.
Yeah.
So I think this algorithm can understand the current scenario according to the incidents that's happening right now, and it can decide its own decisions. So you don't need to train the model, the situations. That was like the problem with like 3 years ago. Right now, they are developing a new algorithm.
Yeah, but I'm speaking from the insurance perspective.
Oh, okay.
Not from the technical perspective, I can do so, no problem.
Okay.
But if I have to die, I would prefer decide it myself, not by a computer. Okay.
Yes.
Yeah, and
this is an open problem. This is an open problem.
Mm-hmm.
Yeah, and I have a third question. It's about the DPUs. Like, because we have a lot of information that are coming from the all over the world. So, do you think like replacing the CPUs with the DPUs is the next futuristic thing that self-driving cars are looking at, because they can directly transfer the data to the servers and let the I mean, because we have faster DPUs instead of CPUs, so they just look at the data processing, not at the computing.
You speak DPUs on server, on cloud computing, or DPUs embedded?
Embedded.
Embedded, yeah, of course. But anyway, an embedded DPU is never as powerful as a cloud computer. So we use DPUs, even GPUs, GPUs like NVIDIA GPUs are kind of DPUs. I mean, they are programmable data crunching architecture. So we do a lot of, we even use DPUs. The idea is that you do as much as you can on board to take fast decision as accurate as you can, because as said, you may not have the time, for instance, for an emergency braking, to send a complete LiDAR frame and camera frame to the cloud and waiting for the answer. Mm-hmm. So you may want to do it locally, okay? It's really complex. It's an open problem, I said, and we are doing research on that. We will certainly have embedded DPUs on board. This is for sure. We already have them for infotainment and cockpit rendering, so we will have DPUs.
Yeah, and my final question. Let's say if the car lose the control and start drifting, so how does the sensors try to it's like worst case, like car is at high speed and it starts drifting, then how will the sensors try to get the car back to the control, like traction control, because it deals with a lot of it's not just bicycle model, it's more complex at that time.
Yeah, actually we did it. We had this very same issue in a race in chess in Las Vegas 1 month ago. We lost control. We did an emergency braking from 250 kilometers per hour to 80 kilometers per hour, and the car lost control. Okay, that was kind of a corner case. The algorithm did whatever they could, but the car smashed anyway into a wall. So there is physics is physics, you know. So
yeah,
there are algorithms that do the best that they can, but yeah, you when you go to the cyber physical world, to the physical world of a cyber physical system, like Murphy's law, Mother Nature is a motherfucker. So there's nothing you can do.
Yeah.
So yeah, there is a limit. There is something that you can do, but you cannot do everything. You know.
Okay. Yeah. Thank you so much.
You're welcome.
Okay, so we have still time for more questions.
Okay, advising. We might have open positions for PhD positions.
Yeah, of course. Yeah, good.
So this is Abid again. I have a request to you. Can you please share the link of GitHub that you showed to us for converting all the network models to the C++?
Yeah, sure. I can share it. I will put it in the chat. Is that okay for you?
Yes.
It's called TKDNN. You find it on GitHub.
Okay, I want to check it.
It's quite a nice community. It's a lot of people. It's a neural network, so we even use it to predict something related to dolphins in the sea. And you can join the effort if you find a bug or if you want to add a feature. Feel free to join. It's specific for CUDA architectures, okay? So NVIDIA GPUs.
Okay. Did you send the message? We just still did not get the message.
Yeah, sorry. I was sending a private message because I was speaking with Stefano before. Yeah, that's the message.
Okay. Thank you.
And this Checo Cats, Francesco, is one of our top researchers.
Okay.
Hello, can you hear me?
Yeah, sure.
Yeah, Marta.
Hello, Paolo. Thank you. What do we need to do an internship with your team as a thesis internship?
Reach out. Just send me an email. I will send. I don't want to steal students to other professors, but if anyone wants, this is my email, and just reach out. We also have startups, so you can even do an industrial internship.
Okay.
Okay, so I will also share this guy here, which is quite interesting. Can I share the screen a second? Because I thought I didn't have time. I just want to show you this. Do you see that?
Yeah.
This model machine is by Stanford, I think, or Berkeley, and you have a lot of questions telling you what the car should do. And then in this case, for instance, it says this car should kill elderly people that are crossing the street with red, so they are wrong, or should kill a family. There are hundreds of questions like that, and well, it's quite bad, this test, because they started even putting black people and women and boys, and so at the end up they give you a report telling what is your attitude towards families, toward elderly people, toward black people, toward boys versus girls. I don't know if you will like the answer that this machine gives you, but yeah, it's quite interesting, and it's an ethical problem, and it's an open problem. Okay, so I recommend having a look at that. I don't know if you will like the answer anyway, the report.
Yeah, very good presentation.
Thanks.
Thank you very much for this talk. Very interesting talk, and to share with us, and of course with our students, the possibilities to work with your company, to do an internship or a master thesis. It's very interesting, yeah.
So thanks for inviting. And also, as said, we can even start cooperation among universities. For instance, we already have a couple of ideas with Stefano Di Gennaro for joint internships between Unimore and Univaxo.
Yeah, good. Interesting. So, do you have more questions to Paolo? Okay, so if there is no more questions, I propose to all of you to stop here. This morning day, first day of this winter school of HiPeRT Master. Okay, so see you on the afternoon at 1:30 p.m. concerning the presentation of Daimler, Mercedes-Benz. Okay, And for the moment, have a good lunch, and see you on the afternoon.
And just one information for the students following us on YouTube. You can meet us at 3 p.m. this afternoon, because the 1:30 talk is only for current E-PiCo students.
Yeah. Yeah, thank you for this precision, Marie-Pierre.
Professor, I have one last question to Paolo.
Yeah?
Yeah. Yeah, so like for the model that they use for the self-driving, he said like you will be using the tire temperature as one of the parameters. So I remember like tire model is one of the complex models. So how do you get the information of the tire? I mean the temperature.
The car that you saw in the picture, the Indianapolis car, is a 800,000 euros car. So I can promise we have sensors even in the tires.
Okay.
But the point is that I'm not really expert in control theory, I must admit it. So if you want to have more details, I can put you in contact with the PhD students that are working. We have many people working on that, and they can show you the model. But as far as I remember, the tire model has a mathematical formulation which is also called magic formula. So you can even understand how much heuristic and how much try and fail is the procedure to get the tire model is the most important part of the car. You can easily win or lose a race by kilometers if you choose the wrong tire. Yes. Look at F1, the Formula One. It's all about tires. Yeah. So it's itself is a PhD.
And I also want to know, like, do you also monitor the airflow, wind flow when you as a part of self-driving control? Do you also consider wind flow, or it's very minute?
Well, I am not personally on the Formula project. I'm more on the city projects. I can say that for sure you have to take that into account, but I'm not that expert. Consider also that racing cars are an operational design domain, an ODD, which is quite a corner case. Okay. So it's really likely that they do have really custom solutions for every project. While when you have city projects, projects that involve cities, they shall potentially be applicable to thousands of vehicles. So you want standard approaches for the speed car, for the racing cars. You typically have custom projects. So I don't know which kind of approach they use to model the airflows actually. If you reach out, I can put you in contact with the team, and if they can disclose some information, they will certainly do. Okay.
Yeah. Thank you. Yes. Thank you so much. That's great.
Can I ask one last question? Sorry.
No problem.
So could you please give more details about the internship stuff? Like, for example, like for my third semester, like, can I apply for an internship in this company or something?
Okay, if you want to do that, we typically have internships at the university. Again, HiPeRT-Lab and HiPeRT-SRL are basically nearly the same thing, but the SRL is a company with its own budget and business and coordination team, and the university has professors and other fundings. So I would recommend, if you are students, to join the university. We will make you work on the very same projects, okay? They will be less industrial oriented, because the company mission is to do technological transfer of the research within the university. So the best option for me, as a recommendation, generally speaking, is to reach out as a student and to join the university group. This is my recommendation. It's easier also from the bureaucracy viewpoint. I mean, through your professors, we can set up a collaboration. There are Erasmus. I don't know if you are European students right now, but there are Erasmus projects. There are Erasmus Plus. There are a lot of programs in Europe where we can share students and efforts, and you can join a lab. Okay. I would recommend going through the university. Then, if you are good and if you like industry, we move you on startup, no problem.
Yeah, thank you.
Welcome.
Okay. Good information. Another questions?
There is a question from YouTube chat.
Yeah.
How important are HD maps in the localization of the vehicle? Aren't SD maps very hard to keep up to date? Isn't that a challenge too?
Yeah, okay, very good question. Okay, HD maps are really important, of course, but they cannot help you so much to solve the localization problem. We have cooperations with other map providers, so no problem. But the problem of localization in a map is more related to your perception, to the ego vehicle perception. If you don't have good sensors, well, you can have as many HD maps as you want, but there is nothing you can do. And the issue is not that we don't have good sensors, is that all the techniques are implicitly approximate for localization. So maybe you need to compute distances out of cameras, so you don't have ultra accurate distance. Of course, HD maps are helpful, extremely helpful. And they are helpful, especially in simulation. So you rebuild the 3D scene of your system thanks to maps. But they don't really solve the kernel, the core of the problem of localization. This is about sensors, basically.
Yeah, just maybe to complete your answer, Paolo. Yeah, I totally agree with the precision of the sensor for localization, but you can also use software sensors. You know, even if the physical sensors are not precise, you can use the information from let's say less sensors, physically sensors, and get the estimation by software sensors with more precision. And you can reduce the cost and you can increase the precision of the estimation of localization.
Yeah, that's the point. But consider, I know pretty well this problem, that if you have, I don't know, it's rainy, or if you have fog, and in this area of Italy, we have a lot of fog, well, so this is the first problem you need to tackle. We like the fact that the city itself can help you. I don't know how many of you are familiar with the drones.
Yeah.
There is this very nice technology which is called Vicon, which is like you use in closed environment to localize the drone, so gives you a reference. So you can, we test our drones in this environment, it gives you ultra precise positioning of the drone. An approach like that could be even used in a city, but then you have to fill the city with cameras.
Yeah, of course.
So yeah, it's a problem. It's one of the research lines. There are many research lines, okay?
Okay, thank you. Thank you for this all clarifications and answers. Okay, I don't know, Marie-Pierre, if there are any questions from the chat. Other questions from the chat, if you see some other questions?
Not anymore.
Not anymore, okay. So if there is no more questions, so I propose to all of you to stop here. Okay, and I would like again to thank all of you for participating to this morning first day. Thank you very much for all the presentation talks. And see you in the afternoon.